Hello, this lesson is going to take polygons, which is what we just finished covering last chapter, chapter 6. And we're going to take polygons and put them in a coordinate plane and determine whether or not it is, say, a rhombus, a rectangle, if it's an isosceles triangle, so on and so forth. Now, in order to be successful in this, you need to make sure you know the properties of each. For example, a rectangle's opposite sides are congruent and diagonals are congruent. The angles are 90, which makes the adjacent sides perpendicular. We know that a parallelogram's opposite sides are parallel and congruent. We know that a scalene triangle has non-congruent sides, isosceles has 2, and so on. In order for you to be successful in this chapter, knowing all of these formulas right here are going to be very, very important. So I suggest writing everything down here because on here it actually helps you out and it tells you when it is going to be helpful to use these different formulas. So for example, the distance formula is useful when you're trying to figure out if the sides are congruent and if the diagonals are congruent. The midpoint formula is helpful when you're trying to determine if the coordinates of the midpoint, if you're trying to find the coordinates of the midpoint of a side, or if the diagonals bisect each other. And then the slope formula is useful when you're trying to determine if opposite sides are parallel, if the diagonals are perpendicular, or if the sides are perpendicular. So our first example is already on this page. It says, is triangle ABC isosceles, scalene, or equilateral? So when we're trying to classify a triangle, we always look at its side lengths, and we look and see, does it have 2 congruent sides, 3 congruent sides, or no congruent sides? In this case, the distance formula is going to be helpful for us. So we are going to use the distance formula for A, B, and C. We're going to find the length of AB, find the length of BC, and find the length of AC. I see here that A is at 0, 1. I see that B is at 4, 4. And I see here that C is at 7, 0. So by knowing these coordinates, we can now plug them into the distance formula and find each side length. So for AB, that's going to be the square root of x2 minus x1, so 4 minus 0 squared plus 4 minus 1 squared. So 4 minus 0 is 0, or is 4. 4 squared is 16. Plus 4 minus 1, 3 squared is 9. This is the square root of 25. So the length of AB is 5. Okay, now I'm going to do BC. So x2 minus x1, 7 minus 4. Remember that the order actually doesn't matter when you're doing this. I could have put 4 minus 7. That would have been okay. Finishing this out, 7 minus 4 is 3, squared is 9. 0 minus 4 is negative 4, squared makes that positive 16. This is the square root of 25, which is 5. So far, scalene is out of the picture. Isosceles and equilateral are only 2 options. In order to make sure that we know that it is one or the other, we need to find the length of AC. So we'll do the distance formula one more time. AC, 7 minus 0 plus 0 minus 1. So this becomes 7 minus 0 squared is 7, squared is 49, plus negative 1 squared, which is 1, square root of 50. Obviously that's not 5, so isosceles is our final answer. You don't really have to reduce this. It's not that necessary, but if you do, that's okay. It's good practice. But in order for this problem, to answer this problem, it's really not that necessary. Okay. Okay, so for this question, I want you to go ahead and draw it out, plot your points, find the answer, and then bring it to class with your notes. Have it as an actual example in your notes, and then just whenever I ask you for it in class, I'll just look for it and I'll look for the answer and I'll check it while you're working. Okay, this example, we're going to prove that ABCD is a rhombus. In order to do that, we first need to show that it is a parallelogram, and then we're going to show that the diagonals of this rhombus are perpendicular. So in order to show that it is a parallelogram, we can find the slopes of the opposite sides and prove that the opposite sides are parallel. So the slope formula is y2 minus y1 over x2 minus x1. We know that A is at negative 2, 0. B is at negative 1, 1, 2, 3, 4. C is at 3, 5. And D is at 2, 1. So we're going to do, I'll do AB first. The slope of AB is y2 minus y1, so 4 minus 0 over x2 minus x1, so negative 1 minus negative 2. 4 minus 0 is 4, negative 1 minus negative 2 turns into plus, so that becomes positive 1. Let me fix that. Positive 1, and so the slope of AB is 4. Now I could have counted that too. 1, 2, 3, 4 over 1. That would have worked as well. Number 2, BC. Actually, I'll go ahead and do CD to check these two. CD, so that would be 5 minus 1 over 3 minus 2. 5 minus 1 is 4, 3 minus 2 is 1. So the slope of that is 4. Next part would be 3, BC. The slope of BC would be 5 minus 4 over 3 minus negative 1. So that would be 1 over 3 plus 1 would be 4. So the slope of BC would be 1/4. And then the slope of AD, last one, would be, let's see, 1 minus 0 over 2 minus negative 2. So that would also be 1 over 4. So yes, the opposite sides are parallel. The next part would be to prove that the diagonals are perpendicular to each other. So in order to do that, we need to find the slope of BD, and then we need to find the slope of CA. So the slope of BD, y2 minus y1, that would be 4 minus 1 over negative 1 minus 2, and this would equal 3 over negative 3, which would be negative 1. So in order for this to be a rhombus, the slope of CA must be the negative reciprocal. So that means the slope of CA needs to be positive 1. So let me change my color. CA is 5 minus 0 over 3 minus negative 2. And that would be 5 over 5, which would be 1. They're both negative reciprocals of each other. Their product is also negative 1. So there is our proof, and we could conclude by saying, since the quadrilateral ABCD is a parallelogram with perpendicular diagonals, it is a rhombus, and that is theorem 6-16. Okay, this question I also want you to add to your notes and do on your own. I'll check it tomorrow for you guys. I want you to tell me if it is a rectangle, and I want you to tell me if it is a square, because remember, it is possible that it could be both. So get this done, just add it in an example in your notes, but get that one done and bring it to me to class tomorrow. All right, the next question, without using the slope formula, verify that NP is parallel to QR, and verify that PQ is parallel to NR. So there's two ways to do this. One of the properties of a parallelogram says that the diagonals bisect each other, and then the other one says that the opposite sides are congruent. If we can prove either one of those two, then that would automatically make that a parallelogram, which would make NP and QR parallel and PQ and NR parallel. So the first way would be, again, as I said, to see if the diagonals bisect at the midpoint. So we could do the midpoint formula of both PR and QN and see if it's the same thing. So midpoint formula, that's going to be basically what I like to call it or what I've called it in class before is like you're finding the averages of the x's and the averages of the y's of the 2 points. So you're going to add the x's and divide them by 2, and then you're going to add the y's and divide them by 2. P is at -2, 3. N is at -5, 2. R is at -2, -1. And Q is at 1, 0. So if I want to find say the midpoint of PR, I'm going to add the two x's, so -2 plus -2 over 2. And then the y's for PR, so 3 plus -1 over 2. -2 plus -2 is -4. Divide that by 2 is -2. And then 3 plus -1 is -2. Divided by 2 is -1. So the midpoint of PR is -2, -1. For QN or NQ, we would do the same thing, except we would use two different points. So in this case, this is QN. So -5 plus 1 over 2, and then 2 plus 0 over 2. So -5 plus 1 is -4, divided by 2 is -2, and then 2 plus 0 is 2, divided by 2 is 1. So there you go. We just proved that this is a parallelogram, which proves that the diagonals the opposite sides are parallel to each other. Now, remember the second method would be to show that opposite sides are congruent. That would be using the distance formula like we did in the beginning, the first example. Use the distance formula and show the opposite sides would be congruent. And then that would be enough to prove that the opposite sides are parallel.